Now, the last part of this chapter is about the acceleration of the plane motion for a rigid body. And in fact, it follows the same concept for the velocity. So if you remember, guys, whenever I want to find the velocity for a general plane motion for a rigid body, I have to use the relative motion analysis. So I know that VB is equal to VA plus VB with respect to A. Now, if I do the derivative, I can find out what is the equation of acceleration. AB will be equal to AA plus AB with respect to A. What is AB? AB is the acceleration of point B on this rigid body. AA is the acceleration of point A, and AB with respect to A is the acceleration of point B with respect to A. As if A is fixed, it is my reference, and I want to see what is the acceleration of B with respect to me located at this fixed reference. Now, I know that, in fact, the acceleration, if I have a general plane motion, then the acceleration will be into two components. One is tangential and one is normal. In the tangential acceleration, I know that this acceleration will stand for the change of velocity, while the normal acceleration will stand for the change of direction. And this means, guys, if you remember, we did the derivation, and AB with respect to A in tangential direction would be alpha cross RB with respect to A, as shown here, while AB with respect to A in the normal acceleration would be minus omega squared times RB with respect to A. So, guys, if I want to find AB knowing AA, I can replace or substitute AB with respect to A tangential and AB with respect to A normal, and then what I'm going to have is a vector equation that could be in plane motion, could be divided into two scalar equations, one in I and one in J. So this is, in fact, the general equation for acceleration. AB would be equal to AA plus alpha cross RB with respect to A. And remember, RB with respect to A is the position of B with respect to A, which means it's AB, not BA, minus omega squared RB with respect to A. And don't forget that the normal acceleration is towards minus RB with respect to A. So it's towards minus AB, which means it's towards BA, right? Now let's take this case, for example. Here I have a piston that is moving horizontally, which means it is moving in a rectilinear motion. Rectilinear motion means that it doesn't have any normal acceleration. Its acceleration is only the tangential acceleration, and this tangential acceleration is always in the same direction. It's not in the same sense, but it is in the same direction of velocity, which means it's always horizontal here for AC. Now, what about A? A is the pin, which means A is fixed. A is fixed means it doesn't have any velocity. It has a zero velocity, and normally it will have a zero acceleration. It's a pin. However, B is moving in a circular motion. So here I have a circular motion for B around A. All right, so if I want to find VB, I can say that VB will be equal to VA, which is 0 plus omega cross RB with respect to A, and this is also applied for the acceleration. AB will be equal to AA plus alpha cross RB with respect to A minus omega squared RB with respect to A. So this means that B has two components, AB tangential and AB normal. AB normal will always be directed in the negative direction of the position of B with respect to A, so it is towards the center of rotation. And don't forget that this B is common between the links AB and BC, which means I'm gonna take this AB here, and then AB here will be equal to AC plus alpha cross RB with respect to C minus omega squared omega squared times RB with respect to C, and I know that AC is horizontal, plus or minus. This could be found from the equation. Now, if I have two bodies in contact, what you have to know here is that if these two bodies are in contact, then the velocity at A will be the same for these two bodies. The velocity in magnitude will be the same, and this means, guys, that the tangential acceleration that stands for the change of velocity will be the same. So since the velocity here is the same, then the tangential acceleration will be the same. All right, so I can say that AA tangential at this gear is equal to a tangential at this gear. However, guys, the tangential the normal acceleration will never be the same here. The normal acceleration that stands for the change in direction of velocity will never be the same. In fact, guys, if I have two gears that are engaged, then omega r for the first gear will be equal to omega r for the second gear, and this is in fact because they have the same velocity. So the velocity is equal to omega times r. And this means, guys, that if omega times r is equal to omega times r, then minus omega squared times r is different than, for the first gear, will be different than minus omega squared times r for the second gear. So if you multiply this equation here by omega, I'm not gonna have an equal sign anymore, since omega for the first gear is not equal to omega for the second gear. I know, in fact, that since this gear is much larger, then omega is slower, then omega is smaller, all right? So omega b is less than omega a, in fact, since the radius of b is greater than the radius of a, and that's why I cannot say that a normal at point A that belongs to the first gear is equal to a normal at point A that belongs to the second gear. So put on your mind, guys, that at this point of contact, they have the same tangential acceleration, but they never have the same normal acceleration. Now, the last case that I'm gonna talk about for the acceleration part of this chapter is the rolling motion. If I have a rolling motion, guys, then at each instant there's gonna be a point in contact with the floor. This point that is in contact with the floor will have at this instant a zero velocity, but it will not have a zero normal acceleration. The normal acceleration will always be this radius here times omega squared, or minus omega squared times r. The point here, which is the center of gravity, will have a horizontal velocity because it is rolling. This is a rolling motion. So this Vg will have a Vg it will have a horizontal velocity. Now this point A here, because it is the contact with the floor and the floor has a zero velocity, then VA will be also zero, but it will not have a zero normal acceleration. So Vg will be equal to Va plus omega cross Rg with respect to A. Now Va is zero, the velocity at A is zero, so that Vg will be equal to R times omega. And if I apply the equation of acceleration, AG, which is also, since G is always moving in rectilinear motion, then AG will also be AGI, and AA, in fact, will have only a normal acceleration, so that's why it is towards J. It's towards G, so that it is in the direction of J, and I know that VA with VG with respect, or AG with respect to A will have two components, alpha cross RG with respect to A and the normal acceleration. So if you replace them and you do the cross product, K cross J is minus I, and I have a minus sign, then this will be alpha RI, and then here I'm gonna have minus omega squared RJ. If you divide this equation into two scalar equations, one in I and one in J, you're gonna have that AG, which is the acceleration for the center of gravity, will be equal to alpha times R, and that A will be equal to omega squared times R. I know this because, in fact, I know that the acceleration at A will be only the normal acceleration, which is omega squared times R, and since VA is equal to 0, then the acceleration at G will be only the tangential acceleration, which is alpha times R. Thank you.